Hi everyone, welcome to my lesson on factoring quadratic trinomials. Today I've chosen two quadratic trinomials to factor. One of them will have a leading term of 1, and the other one, which is the more difficult, will have a leading term of -1. Students have trouble factoring these. Many of them only know how to do trial and error, so I'm going to show you some methods that you can use so that you will not have to use a trial and error method any longer. For the first problem, I've chosen x squared minus 2x minus 15. And in this case, you can see the leading term of x is 1 because there's no number in front of the x squared. If I look at the numbers for the coefficients, the a is a 1, the b is a -2, and the c is a -15. When I am factoring the quadratic trinomial, I'm trying to find two binomial factors which will multiply together to give me my original problem. So I've written a base case there where I have x plus a question mark for first binomial and x plus a question mark for the second binomial. For the first terms there, the x's, you take the first term of the problem, which is x squared, and you put x squared into each of the two positions. After that, we're now looking for two numbers that will give us a product of -15 and a sum of -2. So this is not very difficult. If I list out the factors of -15, there's not too many of them. There's 1 in -15, -1 and 15, 3 and -5, -3 and 5. And correspondingly in the second column, their sums are -14, +14, -2, +2. Now we are looking for the combination that will give us a -2 for the middle term, so the one that I want for my chart is my third row. So I'm going to be using, in the place of the question marks, the +3 and the -5, so I just simply substitute in there. And in order to verify that that's correct, I would use some kind of multiplication of those binomials. Most of you probably know the method of FOIL, but if not, you can use a distributive property. So that one's fairly simple. If the quadratic trinomial does not have a leading term of 1, it's a little bit more difficult, but this is where you do not need trial and error. So the first term there is 2x squared, which means my leading term is going to be a 2. My second term is a 9 for the coefficient, and my third one, the c, is a -5. So for this one, what we're going to do is we're going to multiply the a term by the c term. So I will be multiplying the coefficient of the x squared term, which is 2, by the constant, which is a -5. The product of those two is a -10. So that is the number now that we're going to be looking for products of numbers to give me that will add up to the middle term. So a similar idea to the one that I just did, but I'm not looking for just the back number. I'm looking for the product of the first and the third terms. So again, I've listed out the factors of -10. There are 4 of them: 1 in -10, -1 in 10, 2 in -5, -2 and 5. And again, I'm looking for the sums of those two numbers. So the corresponding sums are -9, +9, -3, and +3. And again, I'm looking for the combination that will give me a +9 for the middle term. And in this case, it's the second row of my chart, which is the -1 and the 10. Now, what I'm going to do with the -1 and 10 is I'm going to take my middle term, which is 9x, and I'm going to rewrite that as a sum of the -1 and the 10. So in the next line there, you can see that I've taken the 9x out, and I've replaced it with -1x plus 10x. By the way, you can do that in either order, so I could have written 10x minus 1x. It is easier if you have a plus sign in the middle of these 4 terms. So I like to keep a plus sign if I can. So if I have the option, I will always keep the third term positive. All right, now what I will do is I will take the middle term, having rewritten it, and I will now break up that 4-termed polynomial into 2 groups of 2 terms. So I will parenthesize the first 2, and I will parenthesize the last 2. And now what I'm going to do is I'm going to do a common factor operation on each of those. So in the first 2 terms, I can take out an x, and that will leave me a factor of 2x minus 1. In the second group, I'm going to take out a factor of 5, and that will also leave me a factor of 2x minus 1. This should happen where the last term of each of those groups becomes a common factor. So in the 2 groups, I have a common factor of 2x minus 1, what I will be able to do now is I'm going to factor that forward. So in the next line, I'm going to take that 2x minus 1, I'm going to cross it off, I'm going to bring it out in front as a factor, and then for the second factor of the answer, I will take what was left that was not factored out. So in the first group, I factored out the 2x minus 1, that left me an x. There was a plus sign in the middle, and in the back group, there was a 2x minus 1 factored out, and that left me a 5. So my final answer for this, 2x minus 1 times the x plus 5, and again, to check this, we would use some method of multiplication of polynomials, probably FOIL, but you can also use some kind of a distributive property. This concludes my lesson. Hopefully you were learning this, and hopefully you can see that you do not need any type of trial and error to solve these problems.